my honor and pleasure to start this last day of this great, awesome conference. And of course, I want to start it by thanking the organizers for all the great work they have done for us. This is my first Python PL, and I'm amazed of this experience. I have had a lot of fun for this day, and I hope you have too. I guess the most thing I love in this conference is all the, of course, besides all the new and old friends I meet here, all the great discussions, all the great talks I see, and all the great new ideas I get at this conference. If only I had all the time to try out those new ideas later back home. By the way, any one of you have never heard of Nick's package manager? Some hands? Great. So I really hope that these talks has that kind of experience for you, so that you get ideas that you can try later, new ideas you can try later when you have the right time and the right place. So let me introduce myself. So my name is Asko Soukka. I'm a Python developer. I think it all started just a hobby a long time ago. It wasn't meant to be anything serious, but then something happened, and now I've been professional for quite some time. So I come from Finland, central Finland, from a small city of 100,000 people called Jyväskylä. It has a university named University of Jyväskylä. And I mentioned I'm not a researcher here, so I'm a developer there. We have internal digital service department where we develop and maintain services for our university, for teachers to better teach students and students to better study, so to keep the university running and bring better results. And I'm working, we have a very small Python team there, so I think what's relevant for this talk is that I work in a very small team. We have only 2 to 3 full-time Python developers there, and depending on the time of the year, we have 1 to 3 student trainers extras. For example, last summer we had 2 very good student trainees throughout the summer. But even if we are a small team, we have a lot of projects, and many of those projects are meant to be maintained for a long time. But it may happen, take it running like a year, that we even touch them. So it's not unheard that we have a new, fresh student trainee who comes working on the 1st of June for the summer, and he gets tasked to make a fix or new feature for some small microservice that haven't been touched for a year. So what's very crucial for us is that we have really reproducible environments for our projects, so that those new student trainees can get their projects running on the first day they come, that they can get the development environment running on the first day, they can make their first commits on the first day, and they even see the results of their changes in our test environment during the first day. I think that's very important to keep them motivated and then invest a lot for the training period and bring more results for us. And the last couple of years we have achieved that. And how we have achieved that students really get working environment on the same day on a fresh laptop, that's the kind of topic of this day. So Python packaging. Who has never seen a Python package installation fail? No hands here. So every now and then when you install a package of Pipenv, it's failed because you are missing some dependency. And even worse, you are installing a wheel from Pipenv and everything looks fine until you run the software. In the best case, it crashes trying to start. On the worst case, it only gives you an error when you are using some feature that requires the library that's not there. So even wheels don't really fix that issue. And even if we could manage all those library dependencies with Python packaging, we still wouldn't be able to manage all the dependencies we need in daily development, or running tests, or making the final deployed packages that run on servers. So I'm afraid that Python packaging alone is not enough to solve that issue for us. We need something else, something outside Python, because of course more and more our projects are using also other languages than Python. you have a Python web service, you use the front end, you write the front end in JavaScript, so you need some specific Node.js versions, all the Node packages also to make the project develop and running and build and everything. So it simply makes no sense to put everything in Python. I have a couple of few more examples. So we do a little bit of so-called robotic process automation. That is, we write code to use legacy user interfaces instead of our employees, to free the employees to do something more productive than just clicking on their mouse. An example of such process is some projects where people need to go to web page, print a form from PDF, then they fill the form with pen and paper, and they post that form, another employee gets that form and scans it again in the digital form, and then that employee uses browser to submit that PDF to the final destination. And how we automate that? We made a simple web form with validation, and then the robotic part of that, it takes data out of that form and burn that data on the PDF form, mix solid PDF, and then use Selenium to automate web browser to actually submit that PDF instead of the employee to the final destination. And at the final destination, everything looks like just like before. So we didn't need to change the legacy system. We can keep it running until we have some new version of that, but we got automated that process. And it might be even better because we can have validation at the very beginning. And even that process, the core is in Python. We use robot framework. It's a Python test automation framework that we also use for robotic process automation. And the same is Python. But burning those files to PDF requires PDF that is not Python, and we need to use a Firefox to update the PDF to web user interface. And anyone here done Selenium testing? More hands, very nice. So you probably know that whenever there happens a browser update, anything can happen. So anything can go broken. And that's something we really don't want to happen in that kind of production environment with robots. So it's important we can not only fix pin or log or Python version, we also need to log a Firefox version and its Gecko driver version. All the versions must be logged down completely independently from the system they are running on. So that nothing can fail on accident. Another example, road code STM. Anyone using road code here? Few hands, lucky you. We were using our road code years ago, and I'm sorry we are not using it anymore. While I was on parental leave, they moved to GitLab because GitLab CI. So road code is a source code management system. It's written in Python, but even the core is in Python. It requires a lot of extra packages around it, non-Python, like specifically Git version and subversion version and databases and RabbitMQ for managing asynchronous processes like indexing repositories. And previously, before they moved to Nix packaging, they provide us a script we were supposed to run as root on our server. And we didn't like that, so we end up always reverse engineering that script and doing the steps manually. Keep our road code version up to date. After they moved to Nix, managing completely, they could manage all their dependencies completely independently from the host system. And they no longer needed root, but they had only one folder on a server, with ownership of their user, and then they could, with Nix, they could bring all the versions they need under that folder, and even do atomic upgrades. So if something fails to bring upgrade, it keeps running the old version, and if everything succeeds, then it puts the new version. And from my point of view, that was a success. So while we were using road code, it was no longer an issue to upgrade it. Only drawback was it took a little bit more disk space because Nix used a lot of disk space. And by the way, I'm no affiliate with road code, but I have very warm memories of road code. And last example is casual scripting. Python is a scripting language, and it's fun to use, it is to use. It's really fun to write a small script to automate a daily task or maybe doing work with it. Except as soon as you need to install some package to do something extra, you need to think, where I install that package? And you have learned that never install that on your system either. You need to use virtual. What is virtual? A few years ago, the virtual was still a separate package. You need to install that somewhere. Okay, nowadays it comes with Python, luckily. And okay, where I put the virtual environment, how I name it. Okay, there are tools to help managing virtual environments, but still environments you need to activate them and deactivate them, and you need separate files to contain the requirements in them. And okay, then if you Pipenv, you will have log files for them, a lot of files for just one script, and you end up using the same environment for many scripts, and then you upgrade some dependency for some script, and it breaks the dependencies for the other script. How nice would it be if you could define all the dependencies of your script inside the script file, and then just magically it would get all the dependencies, execute the script, and you would not only need to think about that. We'll come back to this later. So I hope these kinds of examples help you to understand the topic of my talk. So why we really need to think something outside the Python packaging to make our life with development and testing and building and deploying easier. And of course, you might be thinking about, oh, we use Docker for everything, that is everything, or we use background for testing, and I'm a content user, it is everything. So there are other solutions, but in this talk I will explain to you how Nix could help to solve these problems. So let's say hello to Nix. And by the way, that's a terrible name. Try to Google something with Nix, and you get no helpful results. If you add Nix always or Nix packages, you might get better results, but Nix is just a terrible name for software. Okay, it's short, it's right, but otherwise that's just terrible. It doesn't help that in Nix itself, Nix name means two different things. So at first there's Nix language, you write everything. So that Nix is a domain-specific, purely functional, lazily oriented language for software configuration and deployment. So in short, if you describe some dependencies for a project in Nix, you write in the Nix language in the file. And then under the same name goes the Nix package manager. So those two are tightly coupled. And the package manager is the set of command line scripts, or that command line tools that you use to work with those Nix language files. And of course, package manager would not be anything about packages. And you're able to write all the package yourself. And there are like private package repositories. But the biggest commonly maintained repository is called Nix packages. All these are available at GitHub. And GitHub is the master for them. So Nix packages is the commonly maintained repository of packages and everything written in Nix language. And it doesn't only cover a lot of packages, it also covers everything required to set up and run and maintain and everything for a complete GNU Linux distribution. And that distribution is called Nix OS. And Nix has been there for a while, so you may have heard a long time ago about it, how it was scrappy, it was difficult to use and everything, or you may have started hearing it just lately. And that was not an accident, because this graph shows, I think it's Git commits from the main Nix packages repository, how they are growing at the time. So it really has getting more attention lately for the last few years. I haven't heard it like 6 years ago at all. And it has getting more attraction when it got its first stable releases out, which makes sense. And this is Nix today. So it has a lot of all-time contribution, not as much as many big projects, but enough to be a really big project. And so it's very alive and it's growing. The Nix packages repository has over 40,000 packages. So there are everything you expect to find in like normal GNU Linux distribution are there. And also a lot of packages for many languages. Like interpreters and modules and packages and everything. And it supports Linux and Mac OS officially. All Linux supports also 64-bit ARM architecture, mainly Raspberry Pi 3, I believe. And it's supported by Nix OS Foundation, so there is no any big bad company behind that, but it's fully So as in the previous lecture, it was started as a research project by Elke Goldström, and he's still he's still doing active development on this, but he is no longer like directing our having full control of the NICs. But he has given the control for the community. So there are processes and working groups and process how we propose features for this and how we decide what go there and how. So it's a community development project nowadays. And it has a yearly conference called NICSCon. Next one is in next month in Brno, and I will still not be there. Maybe next year. The biggest bummer is it does not have official support for Windows. And my understanding is it's really hard to make NICs work natively on Windows, but it does work already on Cygwin and Windows Linux subsystem. But there might be some issues on installing it. So you may need to go to the community forum to see if you face some issues. Now to really understand how NICs can do what it does, I'm sorry, I need to try to explain a few NICs terms for you. So that's, I guess, the hardest part, the vocabulary of this thing. So if you write those NICs expressions that are like, for example, functions in files with NICs language, those can be functions that take arguments, so they can produce different results with different arguments. So the first thing that those NICs tools do, they turn those expressions they instantiate those expressions into so-called derivations. And at that point, when those expressions are turned into derivations, it's like internal syntax for them. You don't normally read those. So it knows, it can calculate exact hashes for each of those expressions. And all of the dependencies. So every time some argument or dependency changes, that expression for your package gets a different hash. And that's how it can keep building all the different versions eventually for every package. And when it actually delivers and knows those hashes, it can go to look up. Okay, I need to tell so this package manager is source typical package manager. By default, it builds everything from source, from very ground to up. And of course, if you need to build everything very ground, that will take a day or days. So at that point, when it knows the hashes, it can go to look on at so-called caches. Do you have a ready built output, ready built in a binary for me? And if you have, give it to me, so I don't build it. So two developers build the same expression in different places, the same argumentation, the same hash, and can use the same version. So now we have turned those expressions into actual outputs. And finally, one final term that when you have collections outputs for complete deployment of some software or service, that's called a closure. And I will show a picture of that closure to help to understand that. And at first, this is an example of an expression. It's a function that built in Python package. It doesn't do much itself because it needs a Python environment. It needs to be composed with Python environment to be really useful. But you see, it takes 3 arguments and uses those arguments and in fact name and version and hash from Wi-Fi to build the package. And this is like one level up. It will use that package, define the file, and compose it into Python environment, and maybe add other packages needed while go. And that will output the environment with all those packages. And I mentioned the name closure. This is a visualization for closure for Python tree interpreter. So if I grab the Python tree from this package manager, it knows what are its dependencies. It can form directly graph and like, okay, there are all those dependencies, and at the end they all depend on glibc. And I mentioned that all of those have hashes, and those are visible on the file system. So everything gets built into the special directory /me/store under, so every output has its own hash and own directory. And then when you pull a closure for Python tree, you get a list of those directories. And if you make a tarball of those directories, you can ship them anywhere, and it's like a complete working Python tree. You can even make a list of directories, make a tarball and import it into Docker as such, in a Scratch Docker, and it will work. It has everything it needs to run the Python interpreter. Of course, if you have only those installer paths on Docker image, it's hard to figure out where it's a binary I need to call when I run that Docker image. So that's the theory. And I mentioned Conda. You may think Conda can solve a lot of same problems as this, and it does, and it's easier to use, and it works on Windows. Once Conda works for you, just keep using it, no problem. And the story tells that Conda was actually inspired by Nix because Nix is a much older project, but because Nix didn't work on Windows and Conda had to work to make it a really valuable software. And so they simplified it right in Python and became very successful for side with Python community. But it didn't have all the features of Nix, because in Conda you have packages, you have environment of those packages, but just packages. In Nix, everything is to express knowledge. All packages are expressions, so like package is just a special case of expressions. So Nix package doesn't only contain those packages, but also other goodies to make out of those packages. There are a few lists I want to mention. One very special expression is text live environment tools. Any LaTeX users here? Nice. So you probably handle your LaTeX installation like you install one big text live installation on your machine. And then by the time you install everything you need, when you have new laptop, you start from scratch, and on start get installed the packages you need. Well, this text live environment lets you specify by project what are the packages I really need. So the project can tell that this document requires these text live packages. It will build that text live environment to fly for you, having only all those packages. And you get a new computer, you get that document and that environment, you get those packages from there. So I never had that kind of a lot of experience before. So I'm really fan of that. It has container image tools. So when you can build your package or Python environment in Nix, you can easily put it in the Nix container. So as I just described, you can just grab those patterns in the container, but these container tools help you things like making symlinks inside the container so that you can easily find the binaries inside the container. And then I mentioned it supports Raspberry Pi 3 officially, and it kind of byproduct of Nix packages having tools for cross-compilation. So on your PC, you can compile everything that supports 64-bit ARM to 64-bit ARM. And combining that to Nix's image building tools, which that the Nix package contains tools for an expression to build like ICO or SD card images that you can boot your computer with Nix OS. They may be used obviously for Nixos installer images, but of course you can use it for all images like building kiosks. And combining that with those cross-compilation tools brings you that I have this Python project I want to make a build image for Raspberry Pi 3 so I have a ISO file I burn on this SD card, and then it boots up Raspberry Pi and starts all the services and have my Python software running all automatically or can be built on PC machines. And when the Raspberry Pi SD card goes broken, I can just do that again with one command. And that, there might be a little hiccups yet. It's a new feature, so everything may not compile as easily as I said, but it's evolving, and that's one of those magical things. And last thing I want to mention is KVM system test tools. So in the previous step, Nix has features for building, describing, configuring complete system configurations. So from these system configurations, we can spin up virtual images, virtual machines on KVM, and build network with those then. And then when everything's up and running, which is the big your service there on different machines of the network, you can run testing commands and see that everything is working. And that level of testing, I think you can do it like Vagrant, for example, but is not even close to as convenient, because when you configure this kind of test setup, you can reuse all your expressions for all your packages. So in optimal use case with Nix, you only need to write everything once in one function, and then you can use that function everywhere. To build your development environments, to bring your KVM test setups, and build your Docker images. These kind of batteries you cannot find on content. But of course, these are professional tools, so if they are hard to use, it's because they are professional. But of course, communities that help you and make the documentation better. So they are not difficult just because they need to be difficult. They can be documented and made easier. Okay, that's kind of the theory part, and we are after the presentation. So now I can turn to show you how can you try out Nix by yourself if you really want to. Okay, let's start by installing Nix. So Nix installer can be found from the nixos/nix webpage, and it's just a bash script basically. So you can run it as such, or you can download it and see what it contains, run the command by yourself. It has two kind of, you can install either so-called single user environment or multi-user environment. And I will recommend if you are just trying it out, you should try out single user environment, because that's much easier to clean up if you don't like it. You simply remove one folder, and then maybe there is one source line for that in your shell profile, you need to remove that. And Nix can run completely in user space. Only time it needs sudo during install is to create that /nix directory and make your user own that. And you can skip that part by making that before. So make that directory by yourself, show it, and then you should be able to run the Nix installer completely in user space, no sudo needed. And when you can get rid of it, just remove the /nix directory and you are fine. It's a little like homebrew. And well, on some systems you may see errors. I guess the most popular one has been that you need to disable so-called sandbox builds to get the install done. And if that doesn't help, then go to Ask community. They really try to make it work. So now we have Nix installer running, and when we open the next shell window, we have like Nix command source inside that shell file. So I will explain you the three most basic Nix commands you need to know to use. The first one is this nix-env, and it's like Anaconda shell. So it's the default, your user default Nix environment. You can install packages in there, like inside standard container environment, or like with homebrew. You can install packages with them, you search packages with. Okay, there's a new command generation which only has that Nix and then some commands. It likes to be like new generation CLI for Nix, but it's still a little bit under development, so it cannot do everything, but it has good search, so you can use that for searching packages, inserting packages, your version of it, and then use nix-env to install those packages inside your environment. And when you install it, it just appears in a new path you can use. And then there's, of course, you can ask what packages I have there, and then remove them, when you don't need them anymore. So where does those packages come from? When you install it, it installs so-called channel for your machine. So channel is collections of all those Nix packages expressions. And it doesn't update automatically, so when you install Nix, you have the version you had when you install Nix. And if you want to upgrade your packages, you start seeing, okay, why I have so-called versions and everything. And you run this Nix channel update command, and then after that you can let that nix-env to upgrade all the packages you had installed to the newer versions. And if something goes broken, you can run nix-env rollback to go back to the previous state. So you can have rollbacks, safe rollbacks to previous versions, and so if something, so then keep working. So if that's imperfect, if you upgrade something on everything is broken, I can't do it anymore, I can roll back and have the old version, I can continue working and see the issues later and fix them later. I hope that rollback command examples how you could install with Nix in like ad hoc setup, ad hoc Python environment into the Nix environment. And yeah, and it looks crazy, and probably you don't want to do that. Because there are better ways to have like per use or per purpose and fill out Python environments with Nix. And we go there next. So I guess Nix shell is the gateway to use Nix. It's the gem there. It's originally called build shell. So that if there is some like package expression, this Nix shell was meant to go to the build shell of that expression where you get all the build inputs, build requirements for that package. You got to build the package in the shell. But it has developed into something more, that you can actually create ad hoc virtual environments with that. For example, I just call Nix shell-b and the package I want, and then I drop in the bash shell with those packages. So there can be many packages, Python packages, any packages that are available at these packages. And then I just press S, right, type exit, and I'm out of the shell. Or I can use it without activation, with the run argument, and then exit automatically. And it does all the getting of those packages, and building or fetching them from the internet and the Nix store on the background. It might print out something during the first run, but you don't really care about that. And there's a poor version of that. What it means, it clears your invariant variables when you go into it. It might have good use case when you want to invariantly poor, but usually you also, this might be broken because you accept some invariant variables to be active. But it's good to know if you want a really deep, have pure environment, it's there. And this is example how you can make a Nix shell environment with Python packages. Well, I admit the syntax it's not so nice, but it's powerful nevertheless. So this example drops you in the shell with Python 3.7 and you do NumPy, and then you have the packages you would like to pay there. And as previously, you can work there as expected. And okay, so where are all those things? By the time you run Nix shells, and things work automatically, and then you discover where has all my Nix space went. So all those get accumulating under the Nix store directory. That's by design. But if you want to get rid of them, there's a special command Nix called garbage that will safely get all the packages that are not currently in use out of there and free some disk space. And now there's also options that you can automatically free disk space if there's only some percent of disk space left. And this is the one I mentioned as the third example for where I would like this kind of package management. So you don't only need to use the Nix shell on shell. You can also use it as an interpreter for your scripts. So use it hashtag should configure that script, make that script executable, and configure this script will run using Nix shell. So the Nix shell will read those lines after the first line, starting with Nix shell, and take its command line arguments from those lines. And that's how your script can define its own dependencies. And when you execute the script, it will have all the packages you can define. Without no extra files, no extra word line management. Only need to maybe collect garbage every now and then if you use a lot of these. Now, of course, everything is faster if you don't collect garbage. Then you have always those binaries available when you need them. The more sophisticated version use Nix shell, especially when you have a lot of packages, a lot of requirements. For example, usually in programming projects, you can put everything that in the file. The Nix shell defaults to read file name shell Nix or default Nix. And in this example, it defines a shell environment with Python 3, with SKLN learn package, and a new make. And as usual, it can contain anything there. But now it's everything is in file shell Nix. And now I only need to type Nix shell, and it's called in the environment, or Nix shell run, and it runs the command in the environment. And that's the thing we use at CI. And we also use in that robotic process optimization case. So we are running Jenkins environment, and we only have Jenkins there and Nix there. And every build can get the requirements using Nix shell there. So we don't need to have many Firefox versions installed or very many Python versions installed there or anything. We get everything there when we need it using Nix shell. And if you're doing Travis CI, Nix community maintains Travis CI integration, Travis CI language there, community language. So in the best case, you can have like 2-line Travis CI YAML there. It only defines, okay, use language Nix and run this make inside Nix shell. So no longer you need to think about, is this Node.js project or is this more like a Python project? So which language should I use? They have both have pros and cons. You can only use Nix language and get whatever interpreters you need there. That's very convenient. And of course, that version of the middle version of your OpenGIs. So that's expected. Okay, so two developers install Nix on their computers on different time. They will get different versions of the Nix packages on their computers. And now if we use the simple version I have shown on the previous slides, that with import Nix packages something, they will actually have different versions of the packages. They may run into error, so it may work on some machine and not work on the other machine. And wasn't that exactly the issue we were supposed to fix with Nix packages? That we have reproducible builds and it always works on every machine. So yes, but of course for that you need to lock down your requirements. And the easiest way to do that with Nix is that you lock down the version of Nix packages you are using. And you can do it by locking down the exact commit hash at GitHub. Okay, again, it doesn't look as nice, but it works well. And there's even a tool shipped with Nix that helps you to calculate those hashes. For the URL is a tarball version of that commit hash. So GitHub has had an archive API that gives you the repository at a certain point as a tarball or a chip. And then you need to calculate hash for that unpacked. But there's a helper fund to do that. And every time if you have wrong hash, the Nix build will complain, oh, I was expecting this hash, I got this hash. So in practice you can see what it was supposed to be and then fix it, and then it is working. But this is the way to really have reproducible builds, and they should keep running over year and over year because they always get the same version for about everything. Okay, so now I can use Nix shell. On command line or shell I can work on everything, and I can see all the dependencies I want to see, Python versions and other programs. But what about my IDE? How my PyCharm, how my VS Code can find those things, because they don't know about my Nix shell, and I don't want to type those long Nix store paths there. And for this you can use the command Nix build. So you need to define that environment as a buildable expression. So that was a bit different from the shell expression. There's a way to make these two combine, but that would have a double amount of lines, so I left it off. So that is a version that you can build with this build, and you give it the file, default this, but you can give the file name, and then you give the output directory, okay, what name I want this to be. And now it will build the environment at the Nix store, and then it will find the path from the Nix store and symbolizing that path with the name you have given on the command. So now inside your project we have that enum symboling that will symbol the folder with all the dependencies of your project. And in the best case, VS Code or PyCharm, we actually find that Python binary and that symboling, and then see all the Python packages it has. Sometimes you need to define and configure it manually, but usually they find it automatically. And now everything works as expected. Of course, there's one part. These Nix environments are immutable. You cannot install anything other there. It was even better one if you're running on Nix OS, because in Nix OS, the whole amount of Nix stories is read-only. So it's really like solid. Nothing can change there. So when you IDE process, okay, you have almost all dependency, you are missing this one dependency. You cannot just click and please install dependency for me because it cannot write under the Nix store. That you need to add dependency yourself into the Nix expression and rebuild it. And then the IDE will see the environment change and have all the dependencies for you again. And previously, I told you about the Nix garbage collection, Nix collect garbage. So how I prevent that it won't collect the package I'm currently using? So coincidentally, that symlink you create with a Nix build, it will also make so-called garbage collector log for that build. So as long as you have that symlink in your project folder, Nix collect garbage does not collect dependencies of that build that also you're using there. It will keep running, and only when you want to get rid of them, you remove that symlink, and then you can run Nix collect garbage and you get rid of those and get some free space again. So that's, I think, the most typical use of Nix build in your everyday life. Now the fun things I promised in the description. So now you have everything configured in this nice shiny expression. What I can do with that, for example, you can make Docker images out of that. And as I shown in Nix colors, Nix really composes, you can compose everything with those expressions. And that is how it also works for making Docker images. So Nix packages have special set of functions or expressions called Docker tools. One of them is called build layer image. It takes name of the image and tag of the image minimally, and then the contents of the image. And this is how simple it can be in the single place. I simply import the environment I did specify in the previous slide for the Nix build, same environment. And then that build will result in Docker image I load the Docker and use. And that has all the packages I hosted. And that's a very minimal Docker image you can have. It might be that you can get even smaller images making manually all the optimization, for example, Alpine, on top of Alpine Linux. But I think you save so much time here that a few megabytes doesn't matter anymore. Oh, at the contents I have also added busybox, because if you just build your Python environment there, you can only run Python there. You cannot, for example, do a Docker exec there and see on the cell what's inside the container. Usually you want to at least have busybox there so that you can open the shell inside the container to see what's happening or test the container inside. Of course, that would be also a security feature. So if you don't want anyone to have shell access to the container, you can turn it off. And then the container only has the Python and no shell. So it's a kind of security by obscurity, so that just the normal commands are not there in the container. Of course, some things may expect that there are some Python code can expect that there are some commands available in the container, and you will fail if you don't have busybox add there. So this is how you could use expression like that. Tell your Nix build that Docker expression. The Nix build will always output the path at the Nix store, and in this case, this path happens to be path to tarball. And the tarball can be loaded to the Docker with Docker load command, and then it's just like any other Docker image in the Docker repository. You can push it to the remote repository and let others use it. You can rename it and run it and delete it and everything you are used to do with Docker. Except you don't need to take care of Docker file. No Docker file there. You don't think about the order of the commands in Docker file, how to optimize layers, and how to optimize the build, which order I should organize the commands that I could make fast rebuilds of the image, because Nix build infrastructure will take care of that. They will take care of that, optimizing the caching, everything under Nix store. So as long as no inputs, no arguments have changed, they'll use the previous build and use that to compose the final Docker image. Oh, well, little complexity, there are two different ways to build Docker images currently in Nix packages. First one is that build layer image. It will be optimized to use all the layers available for Docker, so that if you build a lot of images, it will try to make it so that those images can reuse the layers, several layers, and you have all the small layers and they can be reused, and that's like how Docker is advertised to use, maybe. And then the older version, which is just build image, and it will build single layer image, which is not bad, or I think that's neither bad. So, and it has a few extra features. Most important of those is that run as root. So you can, when you are building the image, you can type a script for extra things to add to the image. For example, you can create users there, and you can create the directory there, and some other things you need to be inside the image prepared properly. And that's available in the first one, but is in there. So I think at least with this build image, you have no really use anymore for Docker file. Both of these accept this config argument, that is, which takes all the other options for the container, and all the options available there are available through the Nix practices manual, which actually is the Docker specifications. So that's a place where you control what user is running is the container, and what volumes are there, what ports are exposed, and things like that. So you really have all the features of Docker image with these build tools without Docker. So these don't even use Docker, they just make it tarball. And the first time you use Docker with this is when you load that into Docker. Okay, then one more thing. Sooner or later, so far we have only used the packages available in these packages. Sooner or later you want to run into that I want my own package there, or I want different version of the package there, but it's not there, what I should do. So, okay, so far everything has been very easy, and I guess you can only use Nix this far. Maybe somebody want to go further, but then there's a learning curve because you need to learn how to actually package stuff with Nix packages, make your own packages. And here you need to learn the syntax. It's not as bad as it looked at first. For example, minimal way to package a Python program, which is like Python package with console scripts, would only look like this. So give me Python 3 version of this package, hello world with this name, with this version, using these sources. You give it the source, the path of your source package, your Python program directory where you're developing. It reads a set of pi and you just normal Python packaging. And everything works until you have dependencies. And then you need to start figuring out, okay, can I use dependencies only on these packages? If you can, then it's easy. So there are many kind of different dependencies. Native built inputs are like Setuptools SCM or PyTest runner that you need on the build page of the package. Then there are check inputs if you want to run tests for the package while building the package. You see that the package is working, tests are running before you make the package. Those are generally check inputs. And if your package uses build C extensions, then you need to define C extension libraries in build inputs. And finally, if your package has Python dependencies, runtime dependencies, or other runtime dependencies, like it needs to have like some image matching on its path, then you need to add those into those propagated build inputs. All of this is well described in this packages manual. It's a big portion of the manual for Python packaging. But this going to the advanced side of it within this. And this is like skeleton how it would look like if you in one file would define your package and its dependencies. It will go very fast in the long file. If a lot of dependencies, you simply cannot manage those by hand. Look all the packages, all the dependencies, all the hashes, all the download links. You cannot do that by hand. And that's kind of issue for many languages inside these packages. And then you need to use things called generators to make those Nix expressions for you. And most popular one for Python is called PyPythonix. It has more contributors. But the downside is it's completely separate from the Nix packages, so it may not have all the packages you found with Nix search. So if your package depends on some special package that needs special bit instructions, that may not be available there yet. But well, it has become already, it can help better. Then the second one is called Setuptools. That's made by me only currently. It's used on the different approach, the opposite, so it builds on top of the Nix packages. So whatever other dependencies you get from Pipenv or from your private repositories, it will try to look, do we already have definition for this package in Nix packages, and it tries to reuse that. And that approach is good as well. So I cannot recommend either of those, but also if you use the later one, then you can write this to a GitHub and I will come to help you with that. And finally, this is no extra. Yesterday we had a great presentation of the first black hole image created with Python. I couldn't go to sleep without adding this slide there. So I had to try those instructions. Of course, I had to try them with Nix. So I published an example where there is a Nix expression for getting all the dependencies for building that black hole image, and also building the black hole image. So the expression will actually either result this final PNG, or when running other way, it will show the animations or the process as you saw yesterday on the presentation. And also at the last there is Travis C integration. So you see, so also Travis can now make images of black hole. And at the end of my presentation, these slides will be online. You will have a short list of the most important resources. Okay. So that was a very brief introduction to Nix packaging and managing, going beyond Python packaging with Nix. I thank you all for listening this far. And this representation is online, so you can go to that link and get this representation. And if you can find that repository at GitHub, there's also an example how these slides were built with later, with Beamer library, with later. So it has that later text line environment for building all this. Also building all this at Travis. Okay, then we have time for questions.
Okay, yeah, let's move to the questions. First question. Assuming I have a regular Python app without, let's say, JS dependency, how is Nix better than VM, Featura, and or Pipenv, etc.?
Well, with plain Nix, you can have a developed environment with the correct Node.js version, and maybe the other libraries those Node packages need for building. Like some Node packages have also native dependencies that allow to build some image processing things or things, so you can have all this on the environment. And at the community, there's also package called set called Node to Nix that can convert the whole JavaScript project into Nix thing. Like the easiest way is just to use so in the easiest way, it can bring you the correct Node.js inside the developed environment and word libraries, and you don't need to install them globally.
But it says like, so without JavaScript. So I was asking just regular Python. Just regular Python.
So, can I answer this question? Because if I understood correctly, you were asking why wouldn't you just use Python or Google for something else?
Regular Python.
So the thing is that if you want to have Python with a specific native library version, like for example a fixed OpenSSL version, for whatever reason you want, then Nix is the answer.
Okay.
Because otherwise you have just apt-get, in which you cannot install specific OpenSSL version. So in the end you end up with building the OpenSSL by yourself, and you want this process to be automated, and Nix is the choice for that.
Okay.
Yes, thank you for answering.
So why not Docker?
You don't need it. It's an extra.
Okay.
Because Docker is for sandbox kind.
Yes, Yes. So Docker has its use cases, and we use it because it standardizes the way we deploy software. So either we use Nix or something else, everything is Dockerized. So everything knows how we deploy stuff. But we don't need Docker for managing dependencies.
Okay, next question. Do you think that Nix will be Conda as an ultimate data science package manager?
I don't believe that anytime soon, just because of money. Conda has so much more money behind. They can keep it running more user-friendly and have all the packages, the resources that need. But if you need to do more stuff, like you care about reproducible deployment, you need to use those packages actually in production, then it can be easier to build all those code using those data science packages inside the application. It can help you there.
Okay, next question. Are the packages provided by NixOS built reproducibly?
Yes. I think that's the whole point. They are necessarily not completely it doesn't necessarily yet make exact binaries. They are hoping for to make exact binaries when you build the same package at different place in different time. They are maybe not completely there, they are going in that direction.
Okay, next question. Do you even need Docker with NixOS and NixOS?
Well, if you can run your servers on NixOS, then you don't necessarily need Docker. Of course, if you need Docker, then you need some other way to manage ports and things like that Docker manages for you.
And next question. When we cross-compile software, sometimes small programs have to be run in order to discover some features of target machine. Does Nix handle that?
I don't know. I haven't get so far yet myself. But on Friday there was a very interesting talk about YOLO, and I was thinking that that's something I want to have a YOLO application on top of Raspberry Pi. So I mean that's my gateway to go to learn that cross compilation myself.
Okay, next question. How do you manage Python dependencies which don't exist in Nix packages? Maybe Pipenv inside Nix shell?
Yeah, I think you can make an Nix shell with the Python interpreter and the virtual env, and then make virtual env so that it allows to use the system packages. So then you would have both the Nix packages and you would use virtual env to install packages on top of that. But of course, as soon as you download like a wheel with binary C extensions inside it from Python, those won't work anymore. But as long as the packages are dual Python packages, that should work.
And the last question, how about dependencies for other languages than Python?
Well, most of them have better support in these packages than Python has. Because most of them have simpler packaging story. And so that they can even automatically generate packages and Nix packages. On Python, because we only see the dependency of Python packages by executing them, so those packages and Nix packages are basically all manually taken care of. But on other languages, they can even generate automatically those packages, like in Latin, the text line is made automatically, and Rust is, and Haskell is, and I don't think Node.js probably not isn't because there are so much packages. So probably most languages are better support than Python.
Okay, that's all regarding the questions. There's one question from the audience. Direct.
Okay, so I have a comment and a question. So I will start with the comment. Regarding Docker versus NixOS. With Docker, you're actually fixing yourself to a given distribution of Linux, probably, that you are basing your Docker image on. With NixOS, you can have packages that will build on different distributions. So that's the advantage here, because you might not want to use Docker, for example, for development, because we all probably know that it can kind of pain in the ass in the Python.
Can I correct that immediately? So,
yes, sure.
So with Nix, you can build Docker images from scratch.
All this.
So then they will have all of those versions you really want to, nothing extra. Another question.
can you go to the slide number 28?
28. Okay.
So here we are building a Nix package based on a commit hash of GitHub.
Yes.
Okay, and are we then pushing this, or can we push somewhere this image later on? Like, is there some kind of Nix store or like something that corresponds to Docker Hub registry?
There is that official Nix cache, but it has only packages in Nix packages. So, but you can make one of yourself. You can even serve one of your own computer. So Nix binary cache is just a directory of a lot of files. And Nix packages manual has comments how you serve things like that. We are using Artifactory, that's a commercial product, and it generates remote supports work for us, so we can fast push those build outputs there, and others can use them.
Okay, that answers my question. Thank you very much.